Hello, everyone. Welcome to the My Healthy Home Summit. Thank you for joining us. I'm your host, Caroline Blazovsky. I'm a national healthy home expert and an environmental residential consultant with over 24 years of experience. This summit is designed to educate you about the process of creating a healthy home, to learn how our homes may affect our health and wellness, and the benefits associated with living and working in healthier spaces. We have compiled the most decorated speakers in this arena to help you on your journey. Today, we are joined by Emily Mottram, who will be discussing healthy architecture in our homes and what we need to know when we are constructing and creating a healthy home. Welcome, Emily Mottram. Thank you so much for joining us today. We are thrilled to have you.
Thanks for having me. I'm so excited to be here.
As a leading and sustainable, healthy architect, can you start by giving me a quick synopsis of your background and how you got involved in healthier architecture?
Sure. So I went to architecture school because when I was in high school, I had a fabulous drafting teacher who said architecture school will be hard. So I said, sign me up. That's what I'm going to do. I went to Penn State for architecture school, which was awesome. And even my thesis back then was about recycling and just keeping things from going to the waste or the landfill. So I've always really been interested in it. I've learned now that I'm older. I grew up, my dad was a dairy farmer and I lived farm to table. And I didn't know that was like a cool thing. That was just like how we lived. So I think has been ingrained in me to just kind of be interested in this whole idea of conservation. And I really enjoyed residential structures because I enjoy talking to homeowners and really making a big impact on their lives. And your home is like this thing that, should really support you in your everyday life. So that was how I got into residential. I mean, legally, as a registered architect, I could build a skyscraper if I wanted to, but that's just not really my thing. So that led me into residential architecture back in 2009 when it was considered gainfully unemployed to be an architect. And I thought, what does Maine need? Because my husband and I had moved to Maine. He's from here. And what they really needed was ways to improve the efficiency of their homes because it costs a lot. And the joke in Maine is there's three seasons: there's road construction, there's mud season, and there's winter, right? Like those are the three seasons that we have. And so, what we really needed here was the ability to improve the efficiency of our homes. And so I started working on that as I grew my architecture practice, just increasing my knowledge about it, which was so useful. I mean, even then, we considered before you made any kind of renovation, you made sure that you looked at all the health and safety aspects first. So that was just ingrained in me from the beginning. It helped with renovation projects, but it also, I think, made me a better architect for new construction as well. And I'm kind of a nerd. And so in fact, on my podcast, I always start the beginning of the podcast out and say, prepare to get nerdy, right? Because I was just super into both the efficiency of the structures, the health of the structures, just all these building science tasks. And I will be a perpetual learner and I keep learning, and especially love that you're doing this right now because we're learning so much more about our buildings and the health of our buildings on the occupancy. And that to me is just so, so interesting. So that's my background, how I got to where I am today, just like increasing in knowledge a little bit more. Once I learn something, I'll learn something else. So
So, for our audience, because we have a lot of people who are come from vastly different backgrounds watching the summit, can you talk a little bit about what building science is? Because we throw this term around. You and I kind of are familiar with it because we're in the industry, but to a layman, to someone who's, I just live in my house, I go to work, maybe I'm an accountant, I have no idea what building science is. So just kind of give them a little brief synopsis of what we're talking about when we talk about building science.
sure. And building science is a scary word for people. I also recently heard it termed building biology, which I thought was kind of really fun. Um, Everything in our homes has an impact on everything else. And so building science is kind of understanding the science of what our homes are doing, right? So we have moisture inside of our home from breathing or cooking or taking a shower. And what happens to that moisture? Where does it go? And how does it potentially affect the structure of our building. Then we've got materials in our building. What are we asking those materials to do? And part of the reason why I say that building science is so important is just the materials that are available on the market today are already pushing people towards building better structures, whether you wanted to or not. The advent of going from board sheathing to plywood changed the dynamic. So if the only thing you do as a contractor is use plywood from board sheathing, you've already um, jumped headfirst into the building science world, right? So understanding what that does, both from a structural component, but also what that does to the science of the building, and it changes the dynamic. So building science is actually a layer of diagnostic pieces that go together to help you understand how your building itself is handling everything that's within it, including the occupants, right? So the occupants also have a big impact on building science, both how the building impacts them, but how they also impact the building. So it's kind of big. It's sort of a new field, but not. And it's sort of the evolution of understanding how we build. And there's so much building science in just general construction. So getting people to kind of understand those things in the terms that they understand without always using complicated terms like I'm a building scientist. I would never say that. I'm just a person who is like a building science educator. These are the things I know and the dynamics I understand. And this is how I want you to just take another minute and think about what you might be doing or changing or affecting. So,
So most homeowners, I think that there's an idea that new construction, whether that be they're building a new house, maybe they're moving into a new apartment, is always better, right? We have this concept of, okay, this is brand new. It's got the latest technology. It's better for me. It's better for my family. Let's talk about that myth because I believe it's a myth, but what your opinion is on it. Um, is this true? And why do people have to be concerned today about their home structure, whether it's old or whether it's new?
well, so it's a 100% a myth. That is absolutely a myth, and a myth for a number of reasons. So let's tick off the myths. One, it's not always better, especially because we're talking about the Healthy Home Summit here, right? So let's talk about off gassing, right? If you buy an existing house, you could inherit materials that have gotten rid of a lot of the toxic chemicals that could be associated with new building materials, right? So sometimes if you're a chemically sensitive or have a sensitivity to really anything. I mean, I think Caroline told me once, if you can smell it, you can be sensitive to it. So um, existing buildings can be both pro and cons on that, but sometimes, the materials that they used, 50, 60, 100 years ago might have been better, right? So they could be better for the occupants. I just mentioned while discussing what building science is, that not everybody understands what they're doing with their buildings. So just because it's new doesn't mean that you can't create an issue. Um, as our codes are improving, which I 100% am on board with, they should improve. We should be working towards this. It's groups of people getting together and saying, these are the important things. But our codes are improving, we're actually changing the dynamics of things. So when I talk about high performance homes, I'm also talking about much smaller mechanical systems. But the more efficient we make our mechanical systems, the less able they are to remove moisture from the indoor environment, which means that you could potentially have mold and moisture issues that you wouldn't have in a house that's 100 years old that dries out easier, or with a more traditional heating system. Not that I'm saying that's what you should do, but I'm just saying that not everybody does it well or does it correctly. And in the United States, most houses are built by developers who are more interested in developing the land than they are in the buildings that they put on them. And so sometimes you can repeat a mistake 100 times before you realize that it's a mistake, especially in a building science terms, what we know, what we don't know. So new construction isn't always better for the occupant and the building. It's also, this hopefully won't be taboo to this audience, but it also is not always better for the environment, right? So there is an amount of greenhouse gases that are produced by just getting the material to the job site on the first day, right? So before you ever use it to build anything from it, you have to extract it, you have to transport it to the facility that turns it into a material. How you turn it into a material, depending on what is exactly you're making, can be fairly toxic, both chemically for people and also for the environment. Then you have to transport it to the site. And all 5, 10 guys that are showing up, guys, ladies, women who are showing up to your construction site, all drive their own vehicle generally to the site, right? So there's a lot of greenhouse gas or embodied carbon, or as Lloyd Alter would say, upfront carbon that goes into our buildings. So when you're building new construction, you already are making a huge dent environmentally, and you haven't even built anything yet. So
Mhm.
um, that is
Fascinating.
something in my book that also goes along with building healthy homes and healthy structures. Is how are we planning for what's going to happen for the next generation or the generation after that? And so right now in the building science world, that's a big topic, where starting with an existing house, you already have that embodied carbon, and then it becomes a choice of where does it make sense and when is enough. So
And so, I mean, I can imagine architecture was always difficult, but now with all kinds of parameters that we have, and all kinds of code, it makes it even more challenging every day. However, one caveat to this is that I want us to kind of talk about occupants often think that because a home is built, they are protected. That we talk about code and we talk about that there's a lot of code, but we also had Joseph Stebreck was on talking about what goes into making code, and it's not as protective and profound and as thought out as people think. It's very almost um, minimalistic, and we really don't put as much thought and consideration into making these things as we think we're protected, right? We buy a house, we think, oh, there's no possible way they'd build a house that I'm not fully protected and safe. And that goes along with our products. And people often think that these products that we put into our homes, from our sheathing to our drywall to our cabinetry, has been somehow checked out, has been put through some kind of approval system. Let's talk about that. That there are no systems to protect us in our homes from these types of products.
don't quote me on this number, but I think the EPA has only banned like 6 chemicals since it got started. So that should tell you something about our building materials. And so, yeah, Dr. Joe is the godfather of our industry for sure from a building science perspective. And he's not wrong. Code is, moving kind of in a direction, right? It's however it gets implemented. People don't seem to participate in it until they have an issue and then they want to, do something. Then it's only as good as the towns that have adopted it, right? So, you don't even have to necessarily adopt it. And then it's only as good as the person who actually enforces it. So this is a challenge that I think I have talked about at least once a week for the last 6 weeks or more, probably for more than that, but I know that I have mentioned at least once a week. Is we have the energy code and we have the residential code. And in the energy code in my market, which is zone 6, you can do continuous insulation R5. And it doesn't really tell you what that material is, right? Because it's the code, so it can't be proprietary. But if you read the IRC, the residential section on condensation resistance, it actually tells you that R5 is risky in this market and you really need to be at like 11 and a quarter. So there are a lot of people who are only reading one section of the code and they're not reading the other section of the code, right? And there's so much code to know. So the building departments and the code officers don't even always know this, so they're not catching it. I build high performance homes, and I actually had a code officer say to me, like, this doesn't pass code because it doesn't have continuous R5 rigid insulation on the exterior of the building. I was like, whoa. A, that's not what that says. B, that's a super risky thing. Please tell me you haven't been telling other people that that's what they should be doing, because now you're encouraging other people to do something that's worse than what they were doing. Um, and so, there's so much information to know. And so, as you know, it's incredibly expensive to build right now. People are always trying to find more cost effective ways to do it. And so I've gotten told, well, we could switch from your double stud wall system to continuous exterior insulation. And I said, if they're suggesting to you that you do a continuous R5 layer on the outside of your building, that is not an apples to apples comparison. In fact, that is risky. And I don't want you to call me in 5 years when your walls are rotten. So, like,
Mm-mm.
let's talk about the impacts of these. And thankfully, if it's my clients or somebody else who knows me fairly well, they ask, which is all like, I don't expect other people to know all the things that I know, but hopefully to know enough to ask, like, can I do this? Is this okay? Is this a good substitution? Because there's so many materials available. If you only read one part of something, you'll get half an answer. And it can be scary and
Mm.
definitely not what we'd want people to do. So we definitely don't want building science and better efficiency and better materials to get chucked to the wayside because somebody only followed half of what we want to do. And in these new construction houses, smaller problems can have bigger impacts than, like, if you left a hole in the building in 100-year-old structure, like, what's another hole? But if you have a quarter size hole in a high performance house that has 3 air changes or less, it can rain inside, right? So there's definitely uh the better you get at it, the more a smaller problem can be exacerbated by not following what you're supposed to understand about the dynamics.
And I think as we build newer, and maybe this is a very simplistic way of looking at it, we have newer product, newer ways that we need to utilize that product. Meaning we can't build with the new product the way we used to build in 1950. We have new product, and therefore we have to have a new way to implement that product into the home. And if you don't do that and you start using newer product and building like you did in 1960, you're going to have a problem. You've got to adapt to what the new product needs and utilize it in the proper way. Does that make sense?
Yeah. And I think that's really compounded on when someone will say, like, what are you using for your water control material? And I'm like, well, there are several materials because it's a system. Right. And so I just keep trying to tell people that your products are just part of a system. Right. So you have to kind of understand how those systems work together. It's not just one product. And
Mhm.
especially when you add or introduce a new product to the system, as you're saying, right, that um, has some kind of shift or change or dynamic to the whole process. And it may not be obvious. It may not just be like, I put this here and then I immediately saw this answer. I'm teaching a sustainable design class this semester, and one of them under roofing is like, what happens when your roof leaks? And then the following slide is, but it's not actually your roof that's leaking, right? And it goes through condensation and moisture in the attic and
Mhm.
it condensing on the surface and raining in the attic space, right? And then you see that on your ceiling. So then everyone immediately goes, my roof is leaking because I
Speaking.
have a roof leak on my ceiling. Well, that's not always the case. So,
And I think a good example too is, let's just say you have an attic space and people are used to seeing this open attic, right? You walk up into your attic and you see your rafters and you see your sheathing, and you can see maybe you've got pipes running up through your roof, up through the attic space through the roof. And we talk about spray foam because people kind of know what spray foam is, right? You take this foam and you spray. You decide, oh, it's too cold. My house is leaking a lot of air, and you spray foam this attic space, right, and makes it real tight. Now, that spray foam that you think is just simple, "Oh, I just, took it and sealed up a few holes," all of a sudden changes the dynamic of that attic space. And what Emily is saying is you start to get this moisture. The attic space isn't breathing right anymore. And now you've got all this moisture accumulating, and maybe you have, stale air that's coming up from the attic. I mean, from the lower level from cooking, it gets trapped up there. Maybe you have moisture that gets trapped up there because you have climate changes on the exterior of the building. But just to give people who don't have that understanding like we do a very simple way of looking at it, you spray this foam all over to insulate your attic, and now your attic becomes a problem because you added a product that didn't work well there.
Yeah. I love that you brought up spray foam. So can we talk about spray foam for like half a minute? Because
Yeah.
I'm sure
Yeah.
the spray foam is on your chopping block too. And one thing I just want to say is there probably are some bad products on the market. A lot of times it is a bad installation of a product. Spray foam tends to off gas. So if you have multiple chemical sensitivities, this would be the last thing I'd ever recommend for you to use in your building. But what I'd like to send out there for anybody who's joining on here for your webinar series, builders and architects or homeowners who are working with builders and architects, spray foam is not the material that solves all of our problems. You should be able to have a really good air barrier long before you ever have your insulation in. So using spray foam to make sure you meet your air targets isn't that great of an idea. Two, if you have to wear a hazmat suit to install it, you can't tell me it's good for you. You just can't. I'm not convinced. And secondary, new construction, there's so much moisture in new construction, right? All of our building materials, woods, the if you have any kind of concrete, whether it's a slab in your basement or a slab on grade where you don't have a basement, there's a lot of excess moisture in new construction for the first 2 years or more, which means that everything is going to dry out. And the one thing that spray foam does not do is move. So as your house moves and settles, the spray foam actually separates itself from other things and it can create issues that you didn't previously have as well. And it does not improve the framing of your structure, and 15 to 25% of your building structure is framing, which means that even though you've got a high density of insulation in between your framing, everywhere you have framing, it's like R4, 5, 6, right? So it's actually really not the best material, and we should stop using it as the material that solves issues. We should only use it where we really, really have to. In which case, Maine has a lot of rubble stone foundations. There's pretty much nothing else that sticks to rubble stone. If it's the difference between an uninsulated basement, which is not okay, and spray foam, I might pick spray foam for you in this case, or a really old structure that has no depth and lots of other reasons why you can't do something else. Otherwise, spray foam is not the fix all cure. Please stop using it as if it is. Thank you. That was
Awesome.
my soapbox.
Awesome. Well, let's go to, I know you have a bunch of slides for us. So let's go over to the slides and see what you want to tell us.
There are just a couple of things I wanted to highlight when it comes to building for healthy homes, right? So, our plan for our healthy homes is to make sure that our occupants have the best access to um, a healthy home when they move in from day one. And part of that is resiliency and being able to stay in the home long term. So in the background, you'll see the first house in this 5 lot subdivision that's all solar ready and all high performance homes. One, because they wanted to create a community. That became a really big thing during the pandemic, is how do we connect with our community? Healthy homes to me means also paying attention to those things. In the foreground, you'll actually see a pollinator garden, right? Paying attention to having a healthy home. And Caroline maybe has discussed this in other ways, is um, having grass clippings and mowed lawns, and more people having asthma and paying attention to that, right? So we pay attention to the landscape and how the water moves and drains around the building, because water is the enemy of all of our buildings. But we also want to go for bees and butterflies and pollinator species and plants that are native to the area, and cutting down on the amount of grass that you have. Um, we also have some clients who have chemical sensitivities, and through that, we've actually learned so much about materials and what can create an issue for someone, whether it has a smell, whether it is something that has plastics or petroleum in it. This particular client was really adversely affected by it, and mold critically. So we needed to be very diligent about the materials that we use. And I bring this up in this slide too, because What you definitely want to do is avoid materials that are trying to do something that they inherently don't do on their own. So, like purple and green board in the bathroom that are really promoted as mold resistant materials, they are treated with some pretty nasty chemicals to try to resist mold. However, if you're concerned about mold, I think you should fix the source and not just try to uh, treat the problem. So we definitely never use those because they've got endocrine disruptors and they've got some nasty chemicals. And so think flame retardants, moisture retardants, or stain retardants. Things that are trying to do those things are not very healthy for you. So we try to eliminate those across the board in all of our products, which we learned from working with some people who had some chemical sensitivities, including natural materials. So here you'll see a natural rot resistant cedar shingle that they used on the outside of the house. And part of the reason why I'm showing the concrete wall is actually they had a soy based release agent for the forms for the concrete wall so they wouldn't have petroleum on the forms when they were pouring their concrete walls. This homeowner actually talked to every subcontractor in this project to make sure that they took an extra second or two and thought, do I just use what's conventionally available, or is there another alternative that we could potentially use that would be better for this client? And they didn't have an unlimited budget either. So I want to make it really clear to people that this isn't just a super high end house. This was a client with a budget who also had to pay attention to every material that went into the structure. Um, this is a real quick diagram. The other thing about sustainable architecture that makes it sustainable both in the beginning and in the long term is the simpler you make the structure, the easier it is to build the first time, maintain the second time. I'm talking about not as many bumps and jogs, not as many dormers in the roof, not as many places where water intrusion can create mold or where air leakage can create high heating costs or bring in dirty air. So people always talk about fresh air. It's not really fresh air unless it comes in through a mechanical system and it's filtered, sometimes filtered even through a HEPA filter. So it's just outside air if you open a window. It's definitely not fresh air if you're getting your air leakage through your structure, because then it's moving through your insulation, it's moving through your attic, it's moving through your basement, which tend to be places where people collect things that are less healthy for you. So I pull this slide up here because the simple structures are how we create long term planning for resiliency for our clients and the structures, but also how we maintain a healthy structure in the long run. Lessons we learned, it's critically important to know what's in your materials, right? Like if you're thinking about eating healthy, you think about what's in that. You know, we read the labels when we go to the grocery store. It's the same with our houses. Read the labels, know what's in it, know what affects you. It's vital that the owner also knows how to operate and maintain and monitor the home after you leave. This particular client, I did a walkthrough with afterwards. I said, do you know how to operate your heating system? Do you know how to operate your ventilation system? She's like, I thought they were the same thing. I'm like, glad I'm here. They're two different things. Here's where you change the filters. Here's how you maintain this. And then after I left, she sent me an email the following day. She said, actually, no matter how much we run the bathroom fan, which is where our washer and dryer is, if I'm doing laundry, I can't get rid of the moisture in the bathroom. And I said, do you also have a lot of lint? And she said, yeah, it's really dusty. I said, I think your dryer vent is disconnected. Well, for someone with multiple chemical sensitivity, the heated byproducts of laundry detergent is really, really bad. So because we had this conversation, she was able to identify an issue and then have it taken care of right away. So I feel that it's really important to follow up with our clients, make sure they understand how to live in the house afterwards, especially if you're going from an existing house to maybe a higher performing house because they operate differently. And then having the right team makes all the difference. You want to make sure that you're being heard for what your needs are. This is your house. Um, Water and moisture management. So this is for all my architects and builders out there. a pretty good house, which is, a term that you maybe have heard before, manages moisture migration through all of the building assemblies, right? When I'm talking building science, this is one of the top things that I'm talking about. So, does it keep it out? If it can't keep it out, how does it drain or how does it dry? Failure to do so creates conditions that are ripe for mold, mildew, rot, decay, all of the nasties we think about in our buildings. In the 70s, they had a lot of what they called sick building syndrome because they made these super tight houses, but they didn't understand how interior and moisture could affect those properties. So they had a bad rap for a while and had some pretty sick buildings. And then keep in mind your control layers. So in building science, we call it four control layers: a water control layer, an air control layer, a vapor control layer, and a thermal control layer, right? So understanding, and if you don't know where all of those are in your building, you could create an issue. So thinking about how all of that works, because water is definitely the enemy of our building in all forms. And since I talked about control layers, I thought it was worth popping up this slide. The blue line on the exterior is our water control layer. And I know how that changes with every material when it changes in between everything. When you go from the foundation to your wood framing, to your windows, to how your floor system sits on top of that till it transitions to the roof. And then the red is a air control layer. So we know what all of those materials are through our entire air control layer, and it is continuous and in contact. And if you've ever seen Steve Basic do some of these awesome red line tests on YouTube, you should be able to draw that red line all the way around your structure without picking up your red pen all the way through. And this is another great graphic that I think helps to highlight what I was talking to you about before, which is if the gray part in this diagram is spray foam and the orange part is your framing, you can see there's significantly more heat loss escaping through the orange parts of your structure. And that's generally 25% of your structure. And that's not including windows, which are very, very poorly performing. But understanding the dynamics of what's happening in our building envelope is critically important for creating healthy buildings and then having healthy occupants. Materials, I mentioned embodied carbon and upfront carbon, then resource efficiency, right? We have some materials that are hard to come by. We have old growth wood that was great. Now we're regrowing stuff and it doesn't have the same properties that the original old growth does. Recycled content, one, that we want to recycle things where there's not a bigger environmental impact to doing that. And two, when it comes off your building, you want to be able to recycle it so it doesn't go to the landfill. And then toxins and indoor air quality, which is more what you guys are learning about this whole summit. And last, but hopefully not least, client education and verification. You see on the left-hand side, this is actually an indoor air quality monitor. Even if the only two things that you pay attention to are the temperature inside your house and the humidity that you have at the time, that would be huge in helping to create a healthier environment. You can get just a tiny little humidistat that tells you that information without it. CO2 is good. I like that one because a lot of people work from home. So when you're really tired after lunch, it could be because the CO2 is high in your office. The two pictures on the top right are an infrared camera and a blower door. This is a great thing. Everybody should have access to these two items. It helps to identify problems. You can look for water leaks and air leaks with the infrared camera, and the blower door will tell you how much air infiltration you're getting through your structure. And then on the bottom right-hand side, that's just something that we do as part of our office, which is energy models to see where we're at. The energy model can also tell you how much you're offsetting in carbon emissions and other things while you're planning your projects. So please, please, please understand, educate your clients so that they can understand how to use their space afterwards. I'm showing you a wood stove here on the right-hand side. Those can be super dangerous and a health issue for clients. And unfortunately, in Maine, we'll probably never get people not to have them. So I like to talk a little bit about client education surrounding the things that you put in your house so that you can sleep at night, knowing that they are going to be as safe as possible. So,
So let's talk a little bit about energy efficiency. And
sure.
a lot of the speakers that have come on this summit are talking about the problems associated with it. We want to conserve energy, right? We want to conserve our carbon footprint. However, we are at this quandary point where when we start to get real energy efficient, we start to create these building envelopes and problems if they're not built correctly, right? Some people are just going for energy efficiency. That doesn't mean they're utilizing, like we talked about, if you're not doing it right, building it tight, not doing it right, you're going to have problems. So, is it possible? And you're probably going to say yes. Is it truly possible to build something energy efficient and have it be healthy at the same time?
Yes,
Okay.
absolutely. And I think that everybody on here is definitely bringing up the points that there's not enough education surrounding how to get to that point or how to get to that level, right? Is how do we make sure that it continues to be healthy and also efficient for the clients without creating issues they previously didn't have? And barring a couple of really fluky things, which you just can't always guarantee that someone won't have a random allergy. You've talked to one of my clients who we did so much to remove chemicals from their home, and turns out we think she was allergic to pine,
Right.
which, you know, you can't always control what somebody is going to have a reaction to. So it doesn't necessarily mean that this house will be the perfect house for that client, even if it would be perfect and healthy and efficient for 99% of the other 100 people. You're still going to have anomalies, so we have to prepare for those. But that there is definitely a lot that we can do to create healthy spaces that are also efficient. And as much as I'm a proponent for building it as best as you can as far as efficiency goes, there's also kind of a trade-off between um, going a little bit further with efficiency or having a healthy space, and us as professionals knowing where that limit is.
And that's why when you're considering, I think, doing a new build, you have to look for a team that is going to not only look at code, not only look at energy efficiency, but make sure that they are looking at your health because there are so many things that you can put in. And we'll talk a little bit, other speakers, we've talked about what we call OSB, oriented strand board. We talked about medium density fiber board. These are more engineered lumbers that start to create problems for people with a lot of the glues and resins and formaldehyde. So, and Dr. Seabrook, we're talking about, what's happened to these materials over time and how they've degraded and become more chemically oriented. And now you've got to be concerned about how you're utilizing them in the structure. And you've got to think about who is sensitive and who isn't. And it's so much, it's a lot to take in. So, how do you determine what types of products, where it's okay to go with, let's say, the newer products that may be more chemical based versus something that is more old school, traditional, less chemical, but maybe is going to, not be as energy efficient? How do you make
Yeah.
that
So,
decision? You have a tough
yeah.
job, Emily.
Well, right. And so, like, in theory, the thought that spray foam is, it's a chemical, right? And it's technically has a higher R value per inch, but it's definitely not something that I'm going to be using, right? We're going to work with a cellulose, and even cellulose has borate and it's applied while it's dry, which means that the borate can be in the air, and that can be a trigger for some people versus some of the new wood fiber techniques, which the borate is added as a wet product, which means that it doesn't have as much in the air. Anyway, my theory or thought on that is if I can't throw it in my yard and let it decompose, I'm likely going to minimize the amount that I have to use it, right? It's also part of this whole idea of not having a dumpster on the job site, right? If you
Mhm.
can't get rid of it without a dumpster, you probably don't want it. Now, this doesn't always mean that that is possible, right? You get to these places where, I'm doing a community build. And unfortunately, they just can't afford anything other than vinyl siding, which would not be what we would recommend for everybody. Or concrete is one of the largest emitters of, greenhouse gases. So in our projects where we can afford to do it, we minimize the amount of concrete we have because we need to keep it for skyscrapers, right? They might need to use concrete. I don't need to use it as much in my structure. I can eliminate a slab or I can eliminate, I can put something on piers. So we're trying to kind of weigh the balance between cost effectiveness, the right materials, the what we're trapping inside with us, right? So I might be, especially if health is a really big concern for a client, I might be more apt to use things that are on the outside of their structure that will have less impact on their interior health, right? So we're going to want to use materials. If they have a budget, then vintage, right, which is a better way to call salvage materials or whatever, vintage materials are often great. They take a lot more work. So I have a client who had a lot of old barn boards. They're absolutely beautiful, but his contractor has to pull every nail out of these boards before he can use them. We wanted to make sure that they weren't filled with creosote or other things that
Chemicals, that's right. Like
some
old things from farms can be filled with glyphosate, could be filled with all kinds of heplichlor, like pesticides they use. It's always
yeah,
this balancing act. Like
it is a
everything has a plus
balancing
and
act.
pluses and minuses all around.
So I think understanding your client is definitely a key starting point. And sometimes that means talking to your clients about their health because they may not realize the things that are affecting them. I think most people don't realize how much our indoor environment affects our physical health, which is really interesting. Obviously, if you've got mold in your house and you've been sick, you can correlate those two things. But plenty of people have mold in their house and have been sick and haven't seen it, right? Until you see the mold, you've already got a saturation problem. You've got other issues. But there are so many other endocrine disruptors. You talked about, MDF, you talked about other boards that are in kitchen cabinetry or, people always joke with me. I'm like, don't spend as much money on your kitchen, right? Like that's not the place. People renovate kitchens, although that's what the market would tell you should spend your money on. I'd rather you were healthy and didn't have as much into your, kitchen cabinetry or built that out slowly because there can be a lot of chemicals in that stuff. And so we weigh the balance between chemicals we think are probably harmful for everybody no matter what you are and how you're seeing it. And then chemicals who are specifically bad for that particular client, depending on why they came to you with whatever particular health issue they might have. And then, chemicals that are in the stuff you're going to get, right? Because everybody forgets that, you get down to finished materials, like what's on your hardwood flooring, vinyl, um, we learned the other day can release phthalates for its entire life. Like entire life. We're talking there's stuff put in the 60s and 80s that's probably still really bad for you. Like it's crazy. How long something can off gas or can it get rid of most of the toxic things within a year or two and people are prepared for that and we have extra ventilation or whatever. Like it is a huge conversation.
I,
We've
I
set up
think I don't mean to cut you off. I think you said something so profound and I just want to touch on it. Is that people, when you are going to see an architect, think about your health. I mean, you said it. It was so profound. You think about it when you go to the doctor and you're getting your scans and your blood and your urine, and that's where your mind is on your health. But you need to take that information that you have, whether you have an allergy or you have a thyroid condition or you have autoimmune disease. When you are going to be doing remodeling or construction, you need to let somebody know. And if that architect or that designer or that builder doesn't care about what your health is, you need to find the person who does. And I think if you just go into it with that perspective, you said something so profound that you go into this as this person has to care about your health when you're building. You've already set the game in motion to have a positive outcome.
And I really feel like if you're going to build new, that should be something that you should have access to, because you can go buy a house that can have all kinds of effects on you, some better, some worse. But if you're going to start new, we have to do the best that we can by the client and by, environmental standards. Unfortunately, single family residential construction is, you know, it it's hard to say that it's a luxury, but it's a luxury, right? So it's a luxury to build a new custom home. And so having access to professionals who can help you make that the best thing for you. Sometimes that means that you sacrifice things that you thought you wanted because you're building this brand new house. And we talk about this a lot with pretty good houses. Build for the 99% of the time, don't build for the 1% of the time, right? Like, don't build a formal dining room that you use once a year on Thanksgiving at the expense of your health 99% of the rest of the time, right? Because the first thing that everybody wants me to do is value engineer out the insulation and air sealing and performance of my structure so that they can build a bigger structure or they can get a fancier kitchen. And that's just not what should be important to you when you're building. Health first, helicopter pad last, and the
Nice.
decision tree of importance.
Nice. So, I want to do a little bit of my fast round. And so there's just like a couple questions that I like to kind of throw out there and allow our audience to kind of learn about you and what you're doing in your home.
Sure.
So, the first thing is, what is your favorite room in your house?
My favorite room in my house. Ooh, that's a great question. This is not nerdy, but I really like my office. I spend a lot of time in here, and there's so much to be said for mental health surrounding the spaces that you work in if you work from home or if you work in an office. I have a big 9-foot slider that faces east in my office with a direct view to the outdoors. I can step outside whenever I need to. It makes working from home a pleasure. So that sounds really nerdy to people who probably like to curl up and read a book or whatever, but my home is also my office. So
Oh, it's beautiful. You want to, and a lot of our experts, we've all asked them these questions, and it's amazing. They have so many spaces in their home that they like, and they're beautiful spaces. So I think it's important to have beauty incorporated into a healthy. It's part of health, right? You need to have
yeah.
that. Okay. Second question: what is your favorite activity that you like to do in your home?
Activity that I do in my home. I'm a big reader. And I mean like nerdy things like finance books or building science books um to all kinds of just fiction, nonfiction. So we have a 28 book challenge every year. I think I'm already on book 11 for the year, so I'm winning because it's only early February.
I'm
But
winning.
uh,
I'm winning.
I'm winning. But I really like to read, and I have a great space to read that also has access to a lot of natural daylight, which is important. It's quiet. It's a great kind of just cozy area to sit and relax.
Amazing. And what is one thing in your home from a health standpoint that you have not addressed that you know is a problem?
Well, so I haven't exactly addressed it yet, but we're working through. And here's one thing that I'd like to really encourage people is sometimes you have to chip away at things a little bit at a time. So last year we needed to put a new roof on, and before I decided to do the insulation and everything in my attic space, I wanted to get the new roof on. So I didn't want people walking through my attic or dropping stuff in there or whatever they needed to do when we put our new roof on. So I
Mhm.
need to air seal and insulate the top of my house. I always say with building science, if you went outside in the snow, you'd want to be wearing boots and a hat. The same applies to your structure. Insulate your basement, insulate your attic, air seal those two places. That's the best thing. So I know it's an issue, and I'm working towards it, but I have to chip away one thing at a time.
Yeah, and I think it's true for all of us too. Economics plays a part in everything. So you can't I think people get overwhelmed, like especially when we're talking about healthy homes, they think they have to do everything all at once. And it's really important to know that if you're just you start doing one thing, that one thing can make such a big difference. Don't think that just because you do one thing, it's not good enough because you didn't do 10. You need to start the process. And each time you do something, the house becomes better and better and better. And that's how I view my own house.
And I will say the one thing that I did do, which will seem totally out of place because my blower door number is still somewhat high, is add a ventilation system to my house. So although I haven't gotten to all the insulation and all the air sealing, we did add a ventilation system. And part of the reason why I bring this up is people ask me all the time, well, even in my old house that's a little bit leaky, should I put in ventilation? And my answer is always 100% yes, because a leaky structure doesn't mean fresh air. And it also doesn't mean that you get the air where you need it. So we had really high CO2 levels in the areas that we use for our office. We needed to try to get some air to our office, even though there are leakier places of our house. So that was the thing that I started with.
Mm.
Even though I know I have a lot of other efficiency and energy projects to do as I work through it.
And that's important that, I can't be more of an advocate for testing, either whether it's using some kind of sensor system or hiring a professional to come in. You need to know what your problems are because not every house has the same problems. Every house is uniquely different, just like we're uniquely different individuals. So I'm all like, find out what you have and address it. Just don't throw things in there and just say, oh, well, I think I have this problem. Like you need to know
Right.
because you might not. Um, can you tell people what is one thing after seeing you? Because they're probably all freaked out now. Everybody gets freaked out when they see our talks and they say, "Oh my gosh, I'm doomed. My house is doomed." What's something they can implement right away? Something that is cost effective. It doesn't have to be something expensive. They can start immediately doing that's really going to make an impact in their home.
Yeah, I mean, really, don't get scared, don't get worried, slow. I'd rather see you, make a 10% decision than get overwhelmed by the details and do nothing. So
Mhm.
one thing that I do, and since you just mentioned it, is an indoor air quality monitor. And that will tell you some things about your house. One, um, Maine is a radon state, and so I think everybody should have a pretty good idea of what the radon situation might be in their house. But even if you don't do that, temperature, humidity, and CO2, which are all relatively easy to measure, will tell you some things about your health inside your home. And taking a look at it. And then, if you are having some serious issues, I would take Catherine's recommendation and have somebody actually do physical air quality testing for your structure. But a little monitor might only cost you anywhere from $10 for a humidistat and a temperature to 200 for a larger one that does potential VOCs. And then don't get hung up on the numbers. Um, it doesn't matter so much about the numbers, just that if you see a spike in something, then you've kind of identified, like, you'll see a spike if the CO2 goes up in your office. And it's like, oh, at 9 a.m., this number starts to go up. And then when I leave my office at 5 p.m., this number goes back down. It's like, oh, that's telling you something is happening. So,
And where can people find you and get more information about all the great work that you're doing? But then also, where do you recommend people go to just start researching this topic? If they're thinking about doing a remodel, doing a new build, do you have resources? And then what are the resources that you recommend people start to look at before they even, decide they're going to talk to an architect or talk to a builder?
sure. I have a bunch of resources. First, you can find me www.mottram.com is my website. And that'll lead you down a couple of rabbit holes. One, which is my podcast, which I do on building science, architecture, and female entrepreneurship. So, all kinds of fun stuff over there if you want to just hear me rattle on with my friends. It's kind of like Tuesdays with Maury, more so than, it's lots of great people sharing their information. If you're super nerdy, join us on the BS and Beer Show live on the first Thursday of every month. And I encourage you to join live because the chat box is often really entertaining. There are also a lot of other professionals who join us live, so you can get your questions answered from other professionals who are just tuning in for the show, and you don't get that on the replay. However, if you've missed some shows, we've done over 100 shows. They're all up on YouTube, and they're relatively entertaining for that. But if you're a homeowner and you're thinking about going out, I recommend starting with the Pretty Good House. There's a website, there's a book, there's articles written on it. It is written so that it is easy enough for homeowners to get started. It's just detailed enough for new professionals, architects, and builders who are trying to get a better grasp or understanding on the concepts. It talks about some of the things that I mentioned today on like materials to try to avoid, that isn't as challenging to understand as the red list, which is also a phenomenal resource if you have a chemical degree and you can understand all of the chemical things in that. Unlike the EPA, they are actually banning some chemicals. Um, so if you're a professional and you want to go down a rabbit hole, check out the Living Future Institute, their website and materials. And also, if you're a professional, and since I heard you had Joe Seabrick on here, I'm going to double down on what he said, which is buildingscience.com is a phenomenal resource for professionals to go to and learn, even if the only thing you do, and I hear he told his daughter Christine this when she was learning, is read one article a day till you get through all the articles and then start again so that you understand them more so the second time around. But there are some phenomenal case studies, enclosures that work, designs that work. Just he has tried to make so much of their work public and free. So definitely go to that for resources. If you like a good giggle, Energy Vanguard with Allison Bales, he writes in a very humorous way about some fairly serious topics, HVAC related. So there are some great resources out there and available, and those are just off the tip of my tongue. There could be thousands more. So there's lots of great information. If I was a homeowner, I'd start with Pretty Good House.
So thank you. One, I appreciate you. And I think you did such a good job at bringing it down so that everybody can understand it. Because this is something that I think we all need to understand how our homes operate. We need to understand what we're getting involved with. And I know it's in depth and it's a lot for people, but in order to be able to purchase and make educated decisions, just like you know about your food, you need to know about your home. And you did a great job making that happen for us. So I appreciate you. Thank you for being here. And we love you. Thanks.
Yeah, well, thank you for having me. I appreciate it. Obviously, this is a topic that I really enjoy, and I can't wait to listen to the even more detailed rabbit holes. What don't I know?